Our first regression example is using the data set of my last 23 water bills for my home. My water is metered in gallons and the bill amount is in US dollars. As you can see, a scatter plot has been created of my last 23 water bills. We discussed this a little bit earlier in the lecture notes, but let's just review. On the horizontal axis is the gallons, that's my usage, and on the vertical axis is my bill amount in US dollars. Notice that most of my months I use between 5,500 and 9,500 gallons. But on 2 months, I used a lot of water. My family used a lot of water. This isn't typical, but it is a water bill, and we decided to keep them in the analysis. It doesn't change my predictions if I leave them in or take them out, so we're going to leave them in. Now, as you can see, we've used the Minitab computer software program to fit the least squares regression line to this data. It's plotted in blue on the scatter plot. The regression equation is printed out by Minitab. It says bill amount, that's on my vertical axis, so that would be my y, equals 23.2 plus 0.00767 times gallons. So the way that it comes out is just as it is on the screen, but I'll go ahead and put gallons in parentheses. Notice that gallons is on my horizontal axis. It's my predictor variable. It's the x. So which one's the slope and which one's the intercept? This is the intercept. And this one is the slope. The slope is the value that's multiplied by the x variable. Also notice that the r squared value is contained in this output. Notice there's an r squared and there's an r squared adjusted. We're going to ignore the r squared adjusted and we're just going to use the standard r squared. So our r squared value is 85.2%. Now we can do our example. Use the regression output above to find and interpret the slope. We already said that the slope is 0.00767. So we said in regression to always write the slope over 1. So that's going to be 0.00767 divided by 1. And remember, that's the change in the y's over the change in the x's. And my y is bill amount. And my x is gallons. That's my usage. So, we can interpret this as for every 1 gallon extra consumed on my water bill, we can expect the bill amount to go up because our slope is positive. Notice the positive sign up here in the equation. We can expect the bill to go up by $0.00761. So for every 1 extra gallon of water consumed, we expect the bill amount to increase by $0.00767. To put this on a more relatable scale, if it goes up by $0.00767 for every 1 gallon, that means for every 1,000 gallons, it's going to go up by $7.67, just so you can get an idea of how much water costs. So now let's predict a water bill for 8,000 gallons consumption. The way that we make predictions is to simply plug in our x value into the regression equation. So our predicted amount is 23.2 plus 0.00767 times our x value of 8,000. So we can punch this in the calculator. And I'm going to take 0.00767 times 8,000. And then I'm going to take that amount and add my 2320. And that gives me $84.56. Let's take a look at the picture of the scatter plot one more time. We predicted for 8,000 gallons usage, the bill would be roughly $85. Take a look on the scatter plot. $8,000 is somewhere right in here. So my predicted value is going to be right on the line. That line contains my predicted values. And if you'll notice, that does indeed correspond to roughly $85 in the bill amount. So when you're computing those predictions, you're computing a point that falls on the line. We have already found the value of r squared. It was 85.2%. Some computer packages report the r squared in a decimal form, and you could convert it to a percentage if you want. So r squared from the output is 85.2%. And what's the definition of r squared? You'll recall from the notes, it's the percent of variability in the y's that's explained using x in the regression. So 85.2% of the variability in bill amount is explained using metered gallons as the predictor, or in this regression. So that means roughly 15% of the variability in my water bill is not explained by my gallons used. This would explain why I can't predict my water bill very well. Alright, should I predict a water bill at 20,000 gallons? Why or why not? Let's take a look at the scatter plot again. Notice that my points only go up to 15,000 gallons. I've observed no months of usage at 20,000 gallons. This is called an extrapolation. I can't make a prediction outside the range of the data. So no, this would be an extrapolation. Some final notes on regression. When you're doing regression analysis, we don't ever say that one variable causes the other. We have to do a well-designed experiment to show a causal relationship. There are lots of regression analyses that I could have shown you where there is a strong linear association between two variables, but one doesn't cause the other. For instance, snake bites and ice cream sales are highly correlated. But does that necessarily mean that one causes the other? No. There are lurking variables, in that case, the summertime, that link the two. So what are the criteria for giving evidence about causation when we can't do an experiment? Again, you show a strong association, consistent association, higher doses associated with stronger responses, alleged cause precedes the effect in time, alleged cause is plausible, etc. You have to work harder in that case to show a causal relationship.